Hey stat students, welcome to the first day of October. Please watch this video before coming to class on October 1st, Thursday. So we're gonna do 3 chapters today, but the first 2 not much, but chapter 3 will have a lot more information there, okay? All right, here we go. So here's your assignment. It's from chapter 3. It's only 3 questions, and it's due on Friday by 3:10. Okay. From Tuesday's test, I noticed that some of you like to submit like a Google Doc for the picture. If you want to do that for your assignment, you can. Okay. So check that out if you would like to. I'm thinking of having a quiz a week from Thursday for chapters 1 to 4. Again, chapters 1 and 2, so this will be mainly chapter 3 through 4. Okay? There's only a little bit in chapter 1 and 2 that I need to go over. All right. So the first thing I want to talk about in chapter 1 are what's the difference between data and statistics. You'll see this on page 2. And this is just the only thing that we need to cover from chapter 1. Okay? So when you think of data, this is just simply like the raw numbers, okay, the data you collected. When you think of statistic, there's some kind of calculation involved, okay? So when you collect any type of values, when you take that and then you find, for example, something like the mean, the median, the mode, you remember these words from like middle school and early on in high school mode. If you take like the standard deviation, right? Anything like that, that's considered a statistic, okay? So make sure you use those terms correctly. If the media does not use these terms correctly, but in AP statistics or in the statistics world, that's how we separate those two terms, okay? And then if you look on page 2, or somewhere in that chapter, there's this huge discussion about like the term data. Is that singular or plural? Really, it's either. It's up to you, okay? So you can say data is or data are, okay? But statistic, if you add an S, it's plural, obviously. So as you know, I like to talk about this like in a food analogy. Think of data as anything that's like raw, okay? It's in its natural state. You've just collected it, right? You've just picked it off a tree, or you've just collected it off of a survey or computer. But if you cook that into something, if you process it, it becomes a calculation. So what can you turn this apple into? Applesauce, apple pie, apple fritters, right? Like apple juice, apple cider vinegar, right? This would be a statistic. This would be data. You could think about it like rice. I had some rice like this right here. So considering how you're going to use this, right, you can consider this as a statistic because it went from the raw form to cooked. But what if you're going to take this rice and you're going to do something else with it? You're going to make fried rice or a rice pudding or something where this rice is the data and you cook it into something else. Okay, so perspective is really important as well, which we're going to talk about a little bit later. Okay. This egg, right? So this right now is raw. Do you guys know how to tell if something's raw or cooked? If you spin it, right, and it doesn't spin, that means it's still raw. Okay, but I wish I had a hard-boiled egg. If I did, it would spin a lot faster. Okay, so again, from perspective-wise, this could be data or statistic, but right now because it's raw, we're going to say data. But what if I cooked it? What if I cook that egg Yeah. Okay. See, that would be considered a statistic. Okay. Probably did too much to belabor this point, but I just wanted to show you that. Okay? So there's my snack. All right, so that's it. That's it from period one. Chapter 1. Okay, so you guys get the difference between those two terms. Now let's talk about chapter 2, starting on page 7. The difference between categorical variables and quantitative variables. Okay, so in this unit, we're going to be dealing. Well, actually, this whole class, all year long, we're going to be dealing with two types of data. Okay, categorical and quantitative. So if you turn to page 7, you'll see that there, but there's another page, I think it's page 10, which let me turn to. Yeah, page 10 gives you a little bit more of a definition on this. Okay. So categorical variables are when you're categorizes data. Okay, categorizes data into categories. Okay. So another way you could look at it is like if you had a bunch of bins, like cups, or like those trash cans, right? You have the recycling trash can, you have the green waste trash can, you have like the other trash can, and you categorize them. So that would be like if you picked up a piece of trash, and I pick a piece of trash right here, you figure, okay, should this go into the blue trash can for recyclables? Is it in the black one? Is it in the green one? Etc. Okay. At least where I live, that's how we have 3 different trash cans for that. Okay. So an example of this could be something like hair color. So, black, brown, blonde, green, orange, magenta. It could be gender. Okay. It could be your grade level. Okay. So a quantitative one, this measures or counts. Oops. It measures or counts something. Okay, so an example of this could be time. It could be money. It could be distance. Okay, so a good way to tell the difference between this is it has a unit. Okay, so time might be hours, seconds, minutes, dollars, pesos, RMB, distance, feet, miles, kilometers, etc. All right. Sometimes people get this mistaken as this being numerical. Okay. Not all numerical variables are quantitative. Okay, so please make this clear. All right, this is not true because look, your grade level is numerical. Now, I guess you can make an argument that if you're 12th grade, it measures your amount of intelligence. So a 12th grader would be quote unquote smarter than an 11th grader. No offense, juniors, right? But really, we don't use it like that. Okay, it's categorizing it. But what about something like shoe size? It measures or counts, right, the length of your foot, but it's also in categories as well. So there are some variables that can be used either, okay, that can fall into both categories. I shouldn't say the word that could be used as either variable. It really depends on how you're going to use them. So let's look at an example of age. Okay, is age a categorical or quantitative variable? So if I said, I don't know, I could say like Levi is 5 years old, Eben is 2 years old, Sarah is 12 years old. I could make an argument that the way I'm using this is a measure or a count of the number of years someone has lived. Okay? Well, what if I said, Sarah is between 10 to 18. Levi is between, I don't know, 1 and 7. Eben is between 0 and 3. Okay, so I just place them into categories now. So if you're going to use like that, that could be categorical. But age is like kind of tricky. So don't, again, assume that anything that is numerical is automatically quantitative. It's how you're going to use it. Okay? Take a look at see page 13, the box or the table on the bottom, right below that cyclist right there. Look at those different variables that you see, and you can identify which ones are quantitative, which ones are categorical. So let's start with the quantitative ones, the ones that are measure or count, okay? Like the number of writers finishing, the number of starting writers, the distance, etc., right? Speed, time, right? Those are all quantitative. Now the year, you could make an argument that's categorical or that's quantitative, right? But look how they're using it. They're not using it as a measure. Okay, they're just simply stating the year that one of these winners. Okay, so that would be categorical. Okay, same thing with the winner. The name of the winner. This, I hope there's no trouble understanding. This is categorical. Country origin is categorical. Now the stages, right? The stages, we're not measuring anything. We're just simply stating like, I'm sorry. In this case, we're saying how many stages there were. So yes, we're counting something there. It's quantitative. But if we want to say like something happened in stage 2 or stage 3, by the way, the Tour de France that they're talking about here, it's split up into different stages, like by days, right? So like a cyclist would race on day 1, which is stage 1, and then the next day would be stage 2, stage 3, stage 4, etc. Okay, so it's not measuring the number of stages. I'm sorry, it is measuring the number of stages. It's not categorizing them. Okay, so sorry about that. Even just me explaining it, you can see that sometimes there's that gray area of statistics that comes up. Okay, we'll talk more about that in class. Okay, so now let's get into chapter 3, which is the main part of today's lesson. There are certain types of graphs and tables that I want you to know, and there's certain things I don't want you to worry about, okay? Independence is going to come up in a future chapter. And then Simpson's paradox, it's really simple, kind of silly. Read over that on your own, but it's nothing major, okay? Independence is major, but it's going to come up later, okay? So I'm going to spend time on that later. I think you know what a pie chart, bar chart is, right? Like you've been working on that since elementary. Segmented bar charts might be new, but take a look at that. I'm sure you'll get that. But I want to focus on these 3. And I know you've seen these already, okay? That's the beauty of statistics, or AP statistics. You've come across this in either math 1, 2, or 3, or 8th grade, 7th grade, 6th grade. And you also see it a lot in your other classes like science and probably social studies as well. Okay. So, what is a frequency table? Your textbook, starting on page 20, goes through the morbid example of the Titanic, right? The Titanic that sank. It counts how many people died from which of the classes, like if you were first class, second class, third class, or you're a crew member. And you'll see that table on the top of page 22. Okay? So that is simply a frequency table. How frequent did something occur, right? How many people from first class died, second class, third, and then crew, all right? So that's all a frequency table is. Now, if you wanted to change that into percentages, so a frequency table is just raw counts, okay? But a relative frequency table, you guessed it, look in your textbook, Relative frequency deals with proportions. Okay, and then these proportions can be written as fractions, decimals. Usually it's going to be percentages. Okay, think about that, right? Think about the general public, or ask yourself, like, do you prefer percentages or fractions? You and probably the majority of the world would say percentages, right? They understand that better. But fractions could get a little bit more difficult to understand. But yes, you could definitely write this as a fraction as well, and that would be called a relative frequency table still. Okay. All right. Relative frequency tables can be displayed as bar graphs. So your textbook uses the word bar chart. Let me close the blinds. Sorry about that. Okay. Bar graphs or pie charts. Speaking of pie chart, I had some apple pie yesterday. That was delicious. Apple pie, is that an example of data or statistic? You got it, statistic. Okay. Let's look at now contingency tables. Contingency tables, another thing that you've dealt with a lot. Another term for this that you may be more familiar with, aka a two-way table. Okay, same thing. Your textbook uses the term two-way table. I'm going to use it interchangeably. I tend to say two-way table, but I have to remember that the textbook calls it a contingency table. It's where you have two variables. And classes, think about this again. First, second, third, or crew. Is that categorical or is that quantitative? Okay, yes, we're counting the number of crew members who lived or died, right? But the variable itself. Okay, so if you took one individual, right? If you had one individual from the Titanic and then you asked the person, are you dead or alive? And which of these categories do you fall into, right? They have to choose amongst one of the choices. They're alive or dead, and then choose one of these four right here. So it's categorical. Okay, so this is categorical, and this is categorical right here. Okay. Chapter 3, we're only dealing with categorical. When we get to, this will be chapter 3, and then chapters 4 through 6, we'll deal with quantitative. Okay. All right, so two-way table. Simple, right? But what if we want to change this into what we call a marginal distribution? Okay. Marginal distribution is simply this, but with percentages or with proportions. Okay, it's a contingency table with proportions. Because remember, if you just looked at this 203, like number of first-class individuals who lived, and we compared it to the overall total, like some of you can calculate that. You're like, okay, that's a little less than 10%, right? But the rest of the world may not be able to. So if you calculate that into percentage, and then you see that's what, 9.2%. As soon as you add that for each of these, that becomes a marginal distribution. Okay, and you can see on page 25, you can calculate it. You can do a percent of the row, you could do percent of the column, you could do percent of the overall table. There's many ways you could write it out. Okay, so that's just a difference right there. And I trust that you know how to read this, right? We'll do some examples with that later. Okay, so we're going to end with conditional distributions. Conditional distributions only look at like one row or one column. So let's say I wanted to cover this up. That paper's not big enough. Ooh. You gonna say hi to my helicopter? Man, what if we had helicopters when the Titanic sank? Huh, would the Titanic story be in our textbook? I don't know. Okay. So if we're only gonna look at, let's do this, okay? So let's we only care about first class people, okay? So who cares about the second and third of the crew? Psh, right? These folks, right, if we only wanted to look at these percentages right here, if I asked a question like, of the first class citizens, or first class passengers, how many of them died or how many of them lived, right? So that would be a conditional statement. So the way you would write a conditional statement, you can say something like, of the first class passengers, what percentage of them died? Okay? You can say that, okay? Or you could say, what percent of passengers died given that they were first class passengers? Okay. Pause the video for a moment. Can you read those two statements and tell me, what are they saying? Are they saying something different? Are they saying something the same? Okay, so there are a couple key words here that can tell you something's conditional. The term of, right? Of the first class passengers. So when I look at my table, I'm disregarding the other three columns. Okay, I'm only looking at this first class. Okay, so of the first class, I only care about these folks. Okay, because they're the most important. Of them, what percent of them died? Right? So you know how to calculate that. That would simply just be the 122 out of 325. So the 122 out of 325, whatever that is. Okay? Now let's look at the second statement. Of what percent of passengers died given that? Okay, so given that tells you that it's also conditional. Given that they were first class passengers. So given that they were first class passengers, I only care about this column again. What percent of the passengers died? So same thing, it would still be 122 out of 325. Okay, these are examples of conditional statements or conditional distributions. And you'll see that more on page 27. Okay, if you're only looking at one column, or maybe you only want to care about those who lived, right? You could say like, of those who survived, what percent of them came from the second class? Or if you want to look at this one, given that they were crew members, what percent of them, given that they were crew members, what percent of them died? Okay, so again, of and given are key terms that you have to look at. So you can take those percentages and turn them into what we call a segmented bar chart, which you'll see on page 29. Take a look at that. I'm pretty sure you can understand that yourself. We'll do more with this. We'll play more with this in class on Thursday. Okay? Thanks, guys.